Bismillahirrahmanirrahim. Last time we talked about important features on the internet that have facilitated many trends and technologies later on. We talked about quality of service as one of the most important features on the internet, which promotes distinction and differentiation between the different users and different applications. We talked about fault tolerance, the ability of the network to work under problems or errors. And we talked about security. What else? We talked about scalability. Scalability as the ability of the network to support growing number of users without affecting the performance of the old users. These features on the internet, it took decades to provide these features on the internet with a good level that later on facilitated many trends and technologies. We talked about many trends like video communication or video chatting, online collaboration. We talked about the concept of bring your own device, which facilitates the fact that the content on the internet is actually very customizable to whatever device you have. So whatever device you use to connect to the internet, the content itself will tailor itself to the device that you have, and even the information that gets transmitted over the network, it gets customized based on your own device that you use. So these are major trends that have been facilitated by the features that have been developed over the internet. So what we didn't cover is some recent technologies that have also become widely available, maybe not here in Qatar, but worldwide. These technologies have also been the result or the product of the features that have been facilitated over the internet. So one of these technologies is what we call smart home technologies. And smart home promotes the fact that all your appliances at home, all your appliances like lights, even your microwave at home, your fridge, anything, even people inside the house, when the tenants they go inside the house, they themselves get connected to the smart home network, which collects information from all the appliances, all the people at home, and then it does like magic for you. So whenever you enter the room, the lights will turn on in the intensity that you like it. Once you sit on the sofa in front of the TV, the smart home network will detect this position and it will open the TV for you on the program that you prefer, something like that. So smart home technologies are developed for the health and wellness and good lifestyle of the people inside that house. These smart home technologies have become very, very widely available in the States. So you have many houses in the States now. They have a complete system of software and hardware and sensors, which they get developed sometimes during the construction of the house. And they actually collect information from people. They even sometimes capture your posture and your positions and your movements inside the house, and they tailor even the energy consumption of some of the appliances inside the house based on your preference and based on satisfying or maximizing your user experience. As I said, so when you enter the room, the intensity of the light gets adjusted exactly in the way that you like it. This optimizes even power consumption. So sometimes the house is connected to a cloud, and the cloud usually supports multiple houses, and this cloud will process the information that gets collected from the house and then tries to optimize so many things. Optimize your user experience, optimize the level of energy consumption inside the house. So if you exit a room, it doesn't make any sense that you leave the lights open. So the lights will turn off automatically. The fridge itself gets adjusted, and sometimes you have even a mobile application that you can adjust things at home before you even go in. You can even start preparing food before you come and so on. So these technologies have become more and more widely available. Maybe not here, but in other places. Other technologies Because of the fact that most of us, we use, do you have a question? So most of us, we use wireless networking at home. And even in some houses, especially here, mashallah, in Qatar, houses are big, and you have multi-story houses and so on. And most of us have some problems related to coverage and ranges when it comes to our wireless at home, right? So one of the technologies that makes this really more feasible is what we call Powerline Networking. And Powerline Networking here, you have power lines digged inside the house in all stories, right? And the idea here is to use the power line not only for power transmission, but for also data transmission. So similar to the idea of DSL, the digital subscriber line, that we use the phone lines for exchanging information. Here, we're using the power lines. And the idea here is that we use something that's already deployed for something that it was not designed for. And it's the main idea of DSL. The power lines also have certain bandwidth. And the idea here is that data communication will use a certain frequency range that is not used by the power lines. So this way we can use the power line for data communication. However, this, of course, requires very sophisticated devices that we use as plugs. And what these devices do is that they read the certain frequency range from the power line where we use for exchanging information, and then it gets this data for you, and then it actually sends this information over the network in the specific floor. So you can use this and put one device or two devices upstairs and one device or two devices downstairs, and then you can use the power lines for communication. And these devices, they act as a gateway between the power line network and the normal data network. So you can connect this to a wireless or wired router, okay? And you can exchange information from different stories at home. So that's one of the recent technologies as well that has become widely available. One of the futuristic services or technologies as well is to use broadband even for internet connection. So even inside the house, you may not have a wireless router at all. You have a device that connects you to the broadband network, to the cellular network right away, without having any Wi-Fi device or anything. So this is going to happen in the near future. And the good thing about that is that we're actually using one technology. So whether you are inside the house or outside the house or inside the mall, outside the mall, we're using cellular technologies all the way. So we don't have, of course, this does not necessarily mean that Wi-Fi will die, but this is another technology that makes seamless communication wherever you are, like ubiquitous seamless communication wherever you are. So you are inside the house, you're still connecting to cellular network. So right now, our phone devices, they actually connect to Wi-Fi at home to communicate inside the house, and they connect to cellular if you want to use, or you connect to the internet connection through Wi-Fi to the DSL or to fiber at home and so on in order to get to the internet. So using these technologies, we don't have to have fiber at home, we don't have to have Wi-Fi altogether, so we can connect using cellular network for any type of communication, whether it's voice, video, data communication, anything. So all the devices will connect directly to broadband wireless services. So one of the, I would call it a big challenge or future challenge for the internet is, of course, by all means, security. So security is becoming more and more a huge challenge, and it's one of the grand challenges in just about every country in the world, including Qatar, of course. So Qatar has put so much emphasis on security, especially with the recent trends and events and things like that. Security is becoming more and more critical issue that needs to be existent, and this requires the many technologies to work together, including virus management or virus software, network security, so securing the routers, securing switches, and all levels of communication, as we will study in this course, from the application layer all the way to the physical layer. You need to secure every single layer to make sure that the communication that's happening in this layer is actually secure. So in some cases, we need to use virus software. In some cases, we need to use VPN for private communication. In some cases, we need to use encryption and decryption and so on and so forth. Even for physical layer, there is a new trend or new technology which many researchers have started to work on, including myself, which is the physical layer communication. So we're using even the imperfection of the hardware or the wireless signal to secure the communication. So the security is a big challenge, and I think it will remain like this for decades to come. Okay? So in summary, we talked in this chapter about the impact of networking on the way we learn, on the way we work, on the way we live, on just about every aspect of our life. We talked about many important features on the internet that needs to be in place in order to provide diverse set of services, as we said, including fault tolerance and quality of service and scalability. And we talked about many trends that have become widely available on the internet because of the support of these features, including the video communication and online collaboration and cloud computing, which is what we talked about last time. And also many technologies and future challenges like security that will become more and more critical in the future. Okay? So that's the end of chapter 1. And starting from now, we'll switch gear to a totally new way of running the activities of the class. So what will happen is that first I will give a brief introduction about the topic that we will cover today for chapter 3. Of course, chapter 2 talks about configuring switches and routers and putting operating system and stuff, which will be covered in the lab, as I said. So now we'll start with chapter 3. And chapter 3 talks about, the first section of chapter 3 talks about the rules of communication. So there is a great analogy between communication between human beings and communication that happens between machines. So if we were to look at the communication between human beings, we have to agree, if two people are talking to each other, we have to agree on certain rules. Of course, we don't sit down and agree on these rules, but there are some implicit rules that have to be existent in order for us to communicate efficiently. One of them is the language. So if I tell you Assalamu alaikum and you say like this, we will not understand each other. So we have to agree on a certain language, which dictates certain structure of sentences or grammar. Okay? So we have to structure our sentences properly. Okay? So there are some rules that are related to the information itself and how this information gets structured, or what we say in the exam is related to the message content and structure. And there are some rules which are not related to the content, but they are related to when and how we send this information back and forth. Okay? So the rules that are related to the message content and structure includes how these sentences are structured in terms of grammar, what are the fields, what is the verb, what is the noun, and so on. What is the message size? So if two human beings are communicating to each other and one of them is actually communicating continuous sentences for a very long time, his speech will not be well understood by the other side. But if there is some bidirectional communication, then I need to use short sentences with proper size and then convey my ideas to the other side and then wait for any acknowledgement or any communication from the other side to facilitate the bidirectional communication. The rules that are related to message timing include, as we have seen in this chapter, includes the access method and the flow control. Access method talks about the order of communication. So if two people are communicating, we have to agree implicitly on a certain order. Okay? So I have to say one sentence or two, and then wait for you to reply. Okay? So implicitly, we have to facilitate this bidirectional communication. So who will talk first? If we sometimes, you can try it sometimes, if two people talk at the same time, then it's the conversation will be distorted. We will not be able to understand each other, right? So we have to agree on a certain order. This is what we call access method. Flow control talks about the speed. So once I start talking, I should talk with a proper speed. Otherwise, you will be overwhelmed. So if I'm talking very fast, like I'm doing now, then you may be actually overwhelmed and you will not understand efficiently what I'm talking about. Right? So again, message flow control talks about the speed versus access time that talks about the order. Who will talk first and who will respond. If you talk, I will respond, and so on. This message order is what we call access method. Another very important rule, which is the delivery, what's referred here as delivery options. So if I'm talking to a person and nobody in the room, it's easy. Whatever I'm saying, I'm actually targeting this person because there's nobody around. If I'm talking to a specific person inside a group, then I have to be careful. I have to pinpoint who I'm talking to. Like you person XYZ, then I talk to him and deliver the message. If I'm talking to a group of people inside a larger group, then this is multicast. I have to address the group before. So the main thing here is that if you're talking person to person, there is nobody around, I don't need to identify the person because there's nobody around. If I'm talking to a specific person in a large group, then I have to identify the person. Identifying for machines means addressing. So I have to give the address of the machine that I'm trying to connect to. Okay? And these are the delivery options that have been mentioned in chapter 3 and will be talked about later on in more details. Okay? So the first activity that we need to work on in groups, and the way that this run is that I will ask at least 2 people, and maybe 3 could work as well. Okay? So each 2 people, you and then the one next to you can work on the activity, and then we give you 5 minutes to just finish this activity, and then we'll solve it together. Okay? So this first activity talks about how we structure the message. So we have a letter, which is a content of the message, and an envelope. And the envelope has all the identifiers and addresses and so on. So we need to map these fields to the different places here. Okay? So I will give you 5 minutes, and then we can solve it together. So this is just an example that shows you how to map the different structure of the message into a field format or a message format that can be exchanged between 2 people or 2 machines. This is just a warming up exercise. Later on there will be more sophisticated exercises, and we'll be able to mix and match definitions and things like that. So this is just a warming up exercise. So what is the destination location address?
1400 Main Street.
So this one?
Yes. Canton Oil.
Right? So this whole thing. The sender location address? This one. Okay, type. What is the start message indicator? This is what we say when we first meet each other. Hi. Something that, or salam alaikum, or something like this. Something that indicates I want to start communicating with you. Okay, so this is the word dear. Recipient identifier. This is the person I'm trying to communicate to. So that's me. And the message content is this whole thing. And then the sender identifier is file. The end message indicator, well, it's optional. It's the stamp, just to say that this message is verified and okay, it can go on. This usually in real communication, you don't have to have an end message indicator, except as we will see in the physical layer, in the basement, in the physical layer, very, very way down, and we will talk about why we need an end message indicator. Okay, but in lower layers, when the message ends, it ends. Okay, we don't have to have a proper end of message indicator. In lower layers, we do need end of message indicator, and we will talk about why. In higher layers, we don't need end of message indicator. Okay? So this exercise or this activity talks about the components of a communication system, and the communication system is composed of the message source, the encoder, the transmitter, and then the medium itself, and then the receiver, and then the decoder that corresponds to this encoder, and then the message destination. So we need to match this definition or this function. We need to match this description of a certain function with which component in this system components matches this definition. Easy? Okay. مفهوم الactivity يعني? Okay. When I say pay attention to to each word in this definition, huh? When I say the word interface, this is what the user uses, huh, to use that whole system. Okay? So the word source, I mean on the source side, because as you can see, this communication system is divided into three major components. Three major components. There is the source side, there is the destination side, and there is the medium. Okay? This source side is inside one machine, destination side is another machine, and then you have medium between them. When we look at the source side is divided into three major components. The message source, this is the one that generates the information based on what the user types or enters or something. So this message source is the interface to the user. Okay? When I say source interface to the user, I mean on the left-hand side. So the source interface to the user is what we call a message source. So then, remember the message source generates some information. This information needs to be converted into acceptable form for communication. For example, video, when we capture video, it's a raw video information. If you send this raw video information over the network, you take huge amount of bandwidth. Why? Because if you take the images and then create some samples and for each pixel and then transfer all the pixels over the internet, this will take huge amount of information. And instead, what we do is we convert this video to Ucmpe455, صح? To another form of information which can be transferred over the internet or over the network. So this is the main function of a encoder. So we have MP4 encoder, we have JPEG encoder, okay, and same thing. We have on the browser, we have also some kind of a HTML, which is another protocol that represents the web content into HTML tags that can be sent over the network, and so on. So this encoder, we'll talk about all of this. You don't have to understand all these encoders, but the encoder is the one that converts the information into acceptable form for communication. So this is the encoder. The source interface to the transmission medium. So this is the transmission medium. So the first thing that interfaces to the transmission medium is the transmitter. The transmitter is the one that takes back the digital information after it was encoded, and then it has to convert it to a signal. Because on the medium, I cannot just send ones and zeros. The medium does not understand ones and zeros. At the end of the day, the medium understands signals like this, analog signals.
Oh.
Yes. So this is the main function of the
Digital signals.
digital and analog signals.
Okay.
Okay. هنقبل الكلام ده بحثا بعد. طيب. What recognizes information from the raw data. Decoder بالظبط. اللي هو ايه؟ The reverse operation of the encoder. What's used to send information to the receiver? Immediate. بالظبط. And the receiver interface to the user, this is a the receiver صح, this is a message destination. And the receiver interface to the transmission medium, this is a receiver. Okay? So we will have lots of activities اللي هو ايه matching definition with a function of a proper protocol or a proper system component and so on. خلاص, we'll stop here and continue next time.